All right, well, welcome everybody. Thank you for joining us for our MAQ Informational Q&A. There's a lot of Q's and A's in that title, but we're happy that you're all here. I'm Diana Cox. I'm the Associate Director for Business Development at Risk and Safety Solutions. This is not going to be a heavy sales pitch, but I do want to introduce the organization. We are actually part of the University of California, and we're a software development organization that builds software to help with compliance and safety, environmental health and safety, research safety, healthcare compliance as well, and safety, as well as risk management. So we've been doing that for about 10 years. We have a full staff, developers, subject matter experts, folks like ourselves here on the call. A couple of us are here joining us from the marketing and sales team and the product owner team. But today we are going to actually we're excited to answer your questions about MAQs. We've got Russ Vernon. I'm going to introduce him in just a second. But just as right before, if you want to go to the next slide real quick, thanks. I do want to put out there, if you are looking for a way to better manage your MAQ compliance, we have built an automated way to do so with your chemical inventory and the hazard class data and everything that we have. Russ will talk about that at the end if you're interested, and you can always put in the chat more info if you want to learn more. We'll also follow up with a survey. We'd love to get your feedback on how you think this session went, what other questions you might have, topics, anything else you have you may want to hear in the future from us. So be looking out for that in your email. I am just going to go over a few general items here, just so you guys know kind of what the structure is going to be for this Q&A, not a webinar, because it's not just us talking. We really want questions to be put in the chat. You can raise your hand when we get to the question part, but we're just going to start with introductions. We're going to do a short presentation, about 15, 20 minutes. Russ has told me if he goes too long, we're allowed to, to do the cut him off sign. So there's plenty of time for questions too. We will be here for the full hour, but feel free to come and go as you need to. Some folks did submit questions in advance, so we'll address those first. I think there were about 5 or 6 of those. But like I said, you can also raise your hand or put the questions in the chat. We just ask that you save the questions. We're going to answer the questions after the presentation because the presentation may answer some of your questions along the way. So you can put them in the chat as you're thinking about it. However, just realize we'll answer them at the end. Also, a few things to note. This is for you. This is your session. This is for you to ask any question that you want. There are no wrong questions. There are no, bad things to ask. It can be a simple question. It can be a super complex question. We're going to put Russ. We're going to put Russ to the test today with his knowledge, and we are going to mute you by default. That's just so we don't have to deal with all the crazy, pet sounds, human sounds, safety sounds in the background, whatever it might be. But if you do raise your hand and you want to speak and ask a question, we will ask you to unmute yourself. So you're able to do that, I believe, through your toolbar at the bottom. Like I said, you can drop questions in the chat. We'll do our best to answer all the questions. If you guys have a ton of questions and we can't get to them all, we can either do a follow-up email, a session. We're just kind of playing that part by ear, just trying to see how much we can get through today. And my little disclaimer at the bottom, although Russ is, part of our team, he has years of expertise, very knowledgeable individual. You should always still talk to the fire authority in your area who has jurisdiction when you're making health and safety decisions. So on that note, I will introduce Russ Vernon. So Russ, actually, I've got a little bio for him here. I'm going to have to read it because it's a little bit long. But Russ received his bachelor's degree from the University of Colorado, Denver, and his master's and doctorate from the University of California, San Diego. He had a 2-year postdoc at Scripps Institution of Oceanography, studying colloids in the sea. Russ returned to UC San Diego's upper campus to lecture general chemistry courses and improve health, safety, and environmental compliance in his undergraduate teaching labs. A few years later, Russ moved to UC Riverside, where he managed the research, safety, and environmental health programs before becoming the director of EH&S. Russ joined Risk and Safety Solutions in 2016, and he uses his EH&S business experience and chemical expertise to provide guidance in the development of our safety platform and our MAQ reporting automation. One more paragraph. Russ was challenged with fire code hazardous material compliance in the 90s at UC San Diego. We're making process improvements in the teaching labs in the early 2000s. He was closely integrated with planning and designing for laboratory buildings at UC Riverside with extensive exposure to Cal OSHA and fire code requirements. In his role here at RSS, he participates on the UC system-wide MAQ task force, and that is why he is here to answer your questions. He has been deeply immersed in this for quite some time. That is my intro for Russ. Take it away.
Thanks, Diana. I appreciate that. I see we have some of the real experts on the call, including fire marshals at some of our campuses. So if my answer is I don't know, it doesn't mean we won't look into it. It means that I'll have to get back to you. So the purpose of I really like this cute little graphic. The guy that does our graphics developed this, and it's really information rich. So I won't really go through it a lot, but the goal of the life safety codes is to preserve lives and then preserve property. Most of the things that go into building design related to that have that goal in mind. Here's a list that's very US centric of historical fires, except for the first one when Rome was burning. I watched a documentary where they said that after Rome burned down, Nero built a palace on the site where all the buildings had been destroyed. So there was a little remodeling going on. The first ordinance was in 1631. Don't make wooden chimneys. So with that, strokes. So lots of things have happened over the years. The thrust of all of our experiences have really been to build buildings so that we use fire-resistant materials because life safety is the goal of the fire code. You want to make sure you can get out of a building if it catches on fire to reduce the likelihood of a catastrophic failure of a building. You want to, the code encourages you to segregate hazards into smaller parts that are separated from other parts. That'll be the control area concept we're talking about in a minute. In the modern code, there's a reduction in allowed amounts that as you go away from where the fire department responds to your building. So where the big red truck pulls up and fights the fire, that's where you're allowed to have the most amount of material. Anything below grade or above in the buildings as you go up, you get decreasing amounts. The code gives you credit for having automatic fire suppression systems, sprinkler systems in general. And there is an effort in some parts of the code to try and control the contaminated water that results from fire suppression. There's limits on how much you can actually capture, but that's all part of the code, so you don't damage the environment or other people outside of the building that's on fire. This is what we've learned over the years. There's a lot more than that, but that's kind of a summary. We're here to talk about the limits. It's kind of funny because the code is written in a way, and again, Nick can correct me, but the code's written in a way where you can't do anything except. And so the maximum allowable quantities are exceptions. So you can't store any hazardous materials in this building except for the amounts that they have in the MAQs. It's a difficult way to communicate with normal human beings, but the fire marshals are special people. If you want to be able to calculate maximum allowable quantities and see whether you're in compliance or not, you have to start with a complete, accurate chemical inventory, and that's a challenge. Big chunks of this country don't require complete, accurate chemical inventories for regulatory purposes, but in order to answer the question, are you within compliance, you have to have that. You have to use the hazards as classified in the definitions of the fire code. The fire code definitions have been around a long time. They've modified from about the late 90s, early 2000s. They included some things that are not in the current, the 2016 and later code. Some definitions like irritants aren't in the modern code, but they are in the older code. And the definitions for fire code hazards are different than the global harmonized standard definitions. So there's challenges in the way that happens. In order to calculate the MAQ, you have to know the building features. You have to have identified which rooms are in this control area or that control area. You have to know what the occupancies are. If you're storing things in cabinets or in areas that could be approved. You have to know what is being stored where, so that you can get the credit for approved storage. And then, the part we worry about a lot is the calculations have to be accurate. So one of the issues that we work with a lot is to make sure that we are providing accurate results from the information that we have. Some criteria for the buildings include, one of my favorite, I put this little picture on there, comes from the International Building Code Handbook, is what is the first floor above grade plane? The third bullet point here. So most people would call this the ground floor or the first floor, but that's not always the case. And several campuses in the UC system and elsewhere have buildings built on hills, and so which is the floor that is the ground floor? And it's interesting challenge. I don't have to answer the question in terms of using the software, but you have to identify which is the first floor or the first floor above grade plane, and then you go down from that or up from that, and you get a reduction in how much you can store. You have to know what code year you're applying. There's been a large discussion about what code year applies to a building. Now, clearly, when the building's built, when the plans are substantially complete, is the way the language is written, that's the building code year. And in the California, that would be Title 24. That's when the building code is established. When you're using the building, the question is, do you use the same code year as the building year, or do you use the code year that's current? Because you bring a new bottle of something flammable or toxic into your building, that's an ongoing use. Is that Title 19 that takes over? Which code year do I apply? And it is a challenge. Older buildings are not built for modern MAQ codes. We have buildings in the UC system that are built in the 1800s. And so, what code year you apply is a prescient question, and it requires people that both understand the construction and the intent of the code to be able to answer that. But in our software development, we give the options to the people that are the fire authorities to pick the code year. And then the question about fire suppression systems, there are some things that are only allowed in buildings that are fully protected by an automatic fire suppression system. So that's an important issue. And some of the older buildings I worked with, we had the basement floor was protected by a fire suppression system, but not the rest of the building. So you don't get the credit on the whole building if only part of the building is protected. At least that's the way that I read the code and the way that the Fire Marshal Council at UC's instructed us to apply the code in the software. And then the control area details, right? So a control area is a collection of rooms. Rooms in part of a building are that are segregated by sufficient fire resistant materials. So generally 1 hour firewalls, fire doors, windows, openings, sometimes 2 hour firewalls, windows or openings, depending on exactly what we're talking about. That would allow you to segregate those things into separate control areas. And so you have to know what rooms are in each control area. You have to know what the occupancy is. Most of the MAQ numbers that apply the same way as the B occupancy. So B and R and some of the other ones use the same code, the same table. The mercantile and storage occupancies use a different table. So if you go into Home Depot, they're allowed to store more stuff in Home Depot than you can store in your laboratory, because Home Depot is a mercantile or a storage occupancy. And then how you store it? Do you store it in a flammable storage cabinet? Do you store it in a fumid? Do you store it in an exhausted storage unit? So like for toxic and highly toxic material. And so all those are details that you have to know in order to calculate the MAQ properly. Some of the effects on limits, there are prohibitions of some hazards based on whether you've got sprinkler system or not, and some hazards you can't have if you don't have an improved storage. Like I said, the limits are reduced as you go below the first floor above grade plane or above the first floor above grade plane. And it varies a bit code year to code year how that's applied. Also, the number of control areas you have varies depending on how far above or below you have from the ground floor. And then if you have a sprinkler system, you get more than if you don't. You get to store more stuff. And you get to store more stuff if you've got it all in approved storage. And then I mentioned there's differences in the different occupancies. Here's an example, the B occupancy, which is the most commonly used occupancy for laboratories. You've got at the grade plane, so floor 1, if you will, right here, that gives you 100% of the maximum allowable quantity. And if you have the building constructed in a way that you've got 1-hour firewalls or better between the areas, you can have up to 4 control areas per floor. So you can see here that if you're on the second floor, then you get 75% of what's on the first floor, and you can only have 3 control areas. If you're on the third floor, you get half of what's on the first floor. So a lot of buildings in universities are built like 4-story buildings. On the 4th floor, where they oftentimes put the organic chemists, because the exhaust ducts from the fume hoods are expensive, so you want to have them as short as possible. The organic chemists want to have as much flammable solvent as possible, but you're already limited to 12.5% of what's on the first floor. So when you're designing new buildings, you want to bring this up with people, because that's really important to realize that you're going to be severely limited on how much you can store. In the California system, we have what's called L occupancies, or lab suites, in the international code. That is chapter 38, and there you can store more stuff as you go up or down. You're going to have the percentage is greater. You don't get a double for sprinkler systems, so you already start off kind of handicapped. The percentage is greater, but you only have half as much, if you will, that you would get in a B. But you can have a huge number of laboratory suites, so you can increase the total number on the floor by increasing the number of lab suites, which is almost exactly contrary to what we're doing nowadays. It seems like in construction, we're building these huge open rooms with all these people that interact with each other. And so then you end up being able to store very little hazardous materials. But this is, another example of how it matters what floor you're on, how much stuff you can have. This is a really impossible slide to read. I brought it on to point out a couple of things. Actually, I'm going to cheat just a little bit and slide over the International Fire Code from 2018. It's the same table, but it's a little bigger. And this is the indoor one. You can see these tables are 5003.1.1 doc, parentheses 1, 2, 3, and 4. And these are the hazardous materials. These are the classes if they exist. The other, so this is for B occupancy. If you have more than the allowed amount, like if you've got more than 45 gallons of liquid that is cryogenic flammable, then the occupancy of that room is no longer a B occupancy, it's an H2. So you have to have the construction requirements of H2, or you got to lower the amount you have in storage to meet the B requirements. So this table is also a challenge to read. They've crammed a bunch of stuff into it, but it's the most important table to understand when you're trying to do calculations for MAQs. You'll notice that at the top, if it's in parentheses, that's the alternate unit of measure. So all these are in pounds, but these two up here are in cubic feet. If it's, they all have footnotes. And footnotes vary table to table. The footnote A here is different than the footnote A here. That it's all the magic happens in the footnote when it comes to the calculations. So let me, the other issue I wanted to bring up on these tables is a chemical inventory system can tell you what's in storage, right? It tells you what's in storage. We don't know what's in use. We have use open and use closed systems. So we can calculate the MAQ limit for an open or closed in-use system. But we don't know what you're using. You don't tell us every time you pull a bottle out of a storage cabinet and take it over to the bench to work on it. If we track that kind of granularity, we'd be able to give you this data, but we can generate the limits based upon the building criteria. Oops. Let me move that back. And then see how I'm doing on time. So the hazards that are only allowed in fully sprinklered building in the modern code, so from 2016 to current, explosives, organic peroxides, unclassified detonatable, pyrophorics, unstable reactives class 4, and oxidizers class 4. Those are only allowed in fully sprinklered buildings. And the thing, hazards that are only allowed in approved storage is highly toxic gas and liquefied gas. So if you don't have storage approval for these, it doesn't matter whether you're sprinkled or not, you can't have them. And if you have these in storage, you get double the amount that you do if you don't have them in storage. But if you don't have a sprinklered building, you can't have them stored at all. How do we calculate, how do we determine the hazard categories? This is why they had a chemist get involved. It's a real challenge, mostly because the data is not available and no one's in the business. Well, there are people in the business of taking money from you and testing materials, but it's a big job. So what we do is we apply the fire code. And in this example, pyrophorics, the fire code says it's based upon the auto ignition temperature. So if you know the auto ignition temperature, then you can adequately identify in the code what whether the material is pyrophoric or not. And in this case, it's less than 54 degrees C. Clearly, in the fire code, it's written in Fahrenheit, but it's the same value. It's not. And then if you don't know the auto ignition temperature, which is the most common case for most of the materials we have access to, we look at the safety data sheet. And since OSHA adopted the GHS standard, the standards included the H code 250, which the words on the safety data sheet says it catches fire spontaneously if exposed to air. That sounds like pyrophorics. Turns out that the actual testing methods are different. You don't measure the auto ignition temperature. You break it open on the head of a drum, a metal drum, and watch for 5 minutes to see if it catches on fire. So a lot of the H250 codes are applied to water reactives, not just pyrophoric materials. But this is the process we go through for all of the analysis we do within the software. And this is the kind of thing you need to do if you're doing it by hand. So this is the really simple example. That's why I brought it up with clear numbers. The fire code tells you exactly what the temperature is, the auto ignition temperature you want. If you look at something with a little less clarity, you've got descriptions of organic peroxides, hazard classes that talk about burning rapidly or very rapidly. And then you've got oxidizers that talk about severe increase and moderate increase. So these words are a challenge when you're trying to use data to determine what the hazard classes are. That comes up in this diagram here. You've got, or this slide, some are really clear. Flammability, they ask you for the flash point and boiling point. It's really clear. Also, which definitions apply vary state to state or jurisdiction to jurisdiction, California did not adopt the NFPA 400 standard, which gives you a bunch of ways to test to see what the hazard categories are for some of the hard ones like the oxidizers and reactive materials. But in many states, they take parts of the NFPA standards. In other states, they take the whole thing or don't take it at all. So you have to know what your local jurisdiction has to apply. There's also challenges with the historic examples versus the characteristic data. The NFPA 400, for example, would classify some things differently than what the historic examples are. So that's a discussion you got to have with your authority having jurisdiction. I mentioned the GHS hazard codes are not identical to the fire codes. And, OSHA adopts different versions of GHS. They adopted the version 3, now they're on version 7. The GHS itself has gone beyond version 7. So some of the nuances are built into the new versions of GHS where the old ones weren't. A big challenge for us is IFC's adopted stationary batteries for buildings that have like the ability to store energy in them, and trying to figure out how to accommodate that is a challenge. I'd like to talk about the challenge just a touch here. There are 86 combinations of physical hazard classes and health hazard classes and states that matter. Physical hazards, they describe them in just the solids, liquids, and gases, and then they have separate hazard classes for the pyrophoric or liquefied gases, or pyrophoric, I mean cryogenic or liquefied gases. The health hazards, they talk about them as solids, liquids, gases, and liquefied gases, and there are 3 classes: corrosives, toxic, and highly toxic. There's a lot of information you got to know what hazard class it goes into, and then what category it fits into, to know whether this material of the bottle in your hand is what hazard class it's going to fit into. So how do you determine compliance? We identify the code hazard classes of the materials in the inventory. We calculate the limits based upon the characteristics of the building and whether things are in approved storage or not. And then we compare the inventory to the control area, by control area, to the limits. Does this inventory in this control area for each of these hazard classes above or below the MAQ, the limit? We report the values based upon the control area, and if you have to do this by hand, it's a real pain in the ass. I imagine some people on the call may have had experienced this, but it takes, once you have all the data, once you have all the inventory in your hands, it takes days to go through and identify what the limits are and whether you've exceeded them or not. An automated process you can do instantaneously or in minutes. You still have to get the inventory. So I talked an awful lot. Let me take a breath and start looking at questions. We had some submitted. So let me start with the previously submitted ones. A control area is, in reality, it's a room with a series of rooms, or a collection of rooms with all these characteristics: fire separation, and sometimes the airflow requirements, depending on exactly what code we're talking about. Some of the occupancies require direct exit to the outside of the building, or access for fire suppression activities. So a control area in our world is just a collection of rooms, and then the fire professionals have to verify that the rooms are built properly and have been maintained properly. It's when I was in graduate school, we wouldn't think anything about drilling a hole through the wall and running a cord through so we could connect our instrument over there to the computer over here. But that makes a difference. If the wall you just drilled a hole through is a 1-hour firewall, and you're counting on that to segregate the hazards between the two parts of the building. So in essence, a control area is simply a collection of rooms and in reality, you have to know a lot more about the way the building's constructed, maintained. The next question is a bit more complicated. It asks, if you build a building under one code, can you apply another code on just part of the building in just the way you want to? And I would say talk to your authority having jurisdiction. It's not something that I've ever heard people actually use. Generally, the building that was built under the code as it was built, that's the way all the rules are applied, unless you move to the modern code. And then you move the whole building to the modern code, especially if you've done major remodels. So that I don't know the answer to the question, other than to say that seems really funky to me, to use part of the code for only compressed gases for part of a building. It depends on how it's built, and I wouldn't do that. But talk to your fire authority, whoever it is that actually is in charge of making those decisions on your campus. For use in storage of certain hazardous materials, if the occupancy is converted to an age classification, then the MAQ can be exceeded. But there's no guidelines about what quantity that can be exceeded. There actually are other parts of the code that talk about how much stuff you can have. There's a B occupancy. You can turn it into an H2 by making a 2-hour firewall and doing some other features to the room, and then you can turn it into a flammable storage warehouse if you have these other features. If you're doing a construction job, you can improve the quality of the segregation and fire resistance of the area you've converted, but you really need to look at that. And in some cases, you're right, there are no limits other than the physical limit of the material you can put in the space. In the 2001 code, they had a limit of a control area of 10,000 square feet. That may still apply to some of the hazard classifications, but it depends on where you are, what aspects of which NFPA they might be applying. That's a challenge. How to calculate the MAQ. So the way you do it is, first you identify all the hazard categories, all the chemicals you have, and add them up by hazard category. So how much combustible liquid do you have that's class 2 or class 3, A or B? And then you look at the characteristics of the control area where you're storing the material. Is it in a fully sprinklered building? So essentially, you look at that table, the 5003 table, and you find the number. So let's say the number, well, if I remember correctly, it's been a while, but flammable liquids, I could have 30 gallons of a class 1A flammable liquid. I'm also limited by the class 1A, 1B, 1C first floor. If I don't have a sprinkler system and I'm not storing them in approved storage, if I add a sprinkler system to the whole building, I can store 60 gallons. If I put them in approved storage, I can store 120 gallons. So unless I remember my numbers wrong, but then as you go up the floor, so that's the first floor, the second floor, I get 75% of that. The third floor, I get 50% of that. The fourth floor and above, well, a little ways above, I get 12.5% of the allowable amount on the first floor. So that's how you calculate it. Is it in approved storage? Is the building sprinklered? Is it what's the code year you're applying? What's the occupancy you apply for it? So that'll help determine. And at some point in the future, if you're into, we can go through a manual calculation of this. But I think for today, that's what is going to have to apply. MAQ Informational liquid can be increased to 480 gallons per control area, and the building is equipped with a sprinkler system and chemicals stored inside the flammable storage cabinet. So this is a conflict between whatever occupational safety application is and the fire code application. Oftentimes there's nuances you have to deal with. A storage area, if a storage area is a single room, then that room cannot have more than, it can't be split into more than one control area. So that would be a problem. If a storage area is 2 or 3 rooms and they're in different control areas, then the rules apply for each of them at a time. So clearly a single storage area can't be, it can be small. I mean, it can be a room. It can't be it doesn't have to be a control area, but you can have a storage area that if you've got more than one room in a storage area, you could have more than one control area depending on how it's constructed. Yeah, so that we need to look at some more details and talk to whoever your AHJ is to know the actual answer to how you're going to store the rest of the flammables. You may find that you got to store them in a different building. It just depends on the situation. And I'm almost done. Is there an MAQ for non-sprinkler building? Yes, you can store things in buildings that don't have sprinkler systems, but how much you can store is less than you can in a sprinkler building, and that all comes from the table. All right then.
So Russ, we've got a couple in the chat here. Kevin McSweeney has asked, how are existing locations built prior to control area requirements calculated? Does a new lab fit out create a complete calculation of adjacent labs on that floor or in that building? And if it's easier for you to read it, go to the chat at the top.
Yeah, so that really depends. It depends on whatever your authority having jurisdiction really says you can do. In general, people tend to apply the 2001 code to the buildings that were built before 2001, even the really old ones, because it's a little kinder in some ways if you're trying to limit the MAQs and do that properly. So you would apply the 2001 code to the whole building, not just to the part you're modifying. There is some disagreement among the fire marshals about whether the whole building has to be identified into separate fire control areas, or if I can ignore whole rooms, and not put them in a control area. That's been a discussion. I happen to believe that every structure in the building ought to be identified in a control area, every part you can walk through, but it's a challenge. I would apply the 2001 code to an old building and see what you got to do to make that work out. Do subfloors which double a secondary containment change how an above grade plane is defined for the building? It is, so the definition in the IFC building code, it talks about the finished floor height. And if it's within 5.5 feet above the way you come in from the outside to fight a fire, then it's that finished floor height is the first floor above grade plane. It doesn't, as far as I can tell, it doesn't talk about subflooring, but it does talk about the finished floor height. And some other people on the call may want to jump in. I work hard not to define that for the groups. I point them to the data and say, here, you can tell me. It's a challenge, especially like at UCSF, where they have roads on either side of the building, and one road is up here, another road's down there, and the fire trucks respond to both sides of the building. So can you have 2 first floors above grade plane? I mean, that's part of the question with that question. So however you end up deciding, then you apply the code with that in mind. And Kevin's asking about hazardous waste counts against the MAQ. It does, in the code it does. It's really hard to track hazardous waste and apply the fire code definitions to the hazardous waste to see whether it adds to the amount that's in storage or not. But according to the code, the waste does count against the MAQ.
You scroll down in the chat, Kathleen Hendrickson has the next question there, Russ.
So the location of your building applies in 2 ways. One is with respect to whether you're allowed to build a building of a certain type in that area. The other way is exhaust from the building, whether that's going to be a downstream effect if you're exhausting things from the building. And then finally, just the separation. Most modern laboratory buildings require distance between the building, largely so the fire trucks can pull up alongside them. But you need, I believe, a 50-foot setback between one building of one type and adjacent buildings. So I would be concerned about putting high hazard buildings next to sensitive receptors. So I mean, that's a building code question and a siting question. It's not really an MAQ question. So I can sidestep that one, but I would certainly be worried about it. And I've been involved in many buildings where the neighbors didn't want the building in that part of the campus because they thought it was going to cause problems to them. So I understand that, but it's not in the MAQ code.
Okay, I was going to say, give a thumbs up. That's perfect. I just want to make sure it answered your question.
Yeah.
And Jeff Lewin had a question there. If you want to.
Yeah, I see the MAQ increase. So if you have, just for grins, let's say you're allowed a pound of something on the first floor of a building and the building's sprinklered, that means you're allowed 2 pounds. So you get doubled. And if you put all of those materials in a approved storage, then you're allowed 4 pounds. So you double the amount that's stored. And if it's not sprinklered, but you have a approved storage, then you get 2 pounds for it. So you do literally just multiply, you get 100% of what's there. So you multiply it by 2. So they both exist. So you're right. If it's, you get 1 pound, if it's sprinklered, you get 2 pounds. And if it's got a approved storage, you get 4 pounds.
If anybody at this point wants to raise their hand too and ask a question, we encourage that, or you can just drop any other questions in the chat. How's Rod? Andrew, you'll need to unmute him because he can't unmute himself.
Okay. Hi, everyone. Hi, Russ.
Hi.
I have a question about storage of flammable chemicals. So as we discussed, if, for example, MAQ for class 1, 2, 3 is 120 gallons. If the building has a sprinkler system, it can increase 100%. It reach to 240. And then if you store them inside a cabinet, it can reach to 480.
That's right.
But how should we store them? According to OSHA, we can have not more than 3 60-gallon cabinets, which it gets to 180 gallon. So how should we store the rest of them?
Well, if you build the building so you've got multiple control areas, then you could put some in this control area, some in that control area, some in that control area.
Yeah, but we have only one control area. One control area, the limit is 480 gallons, but we can store only 180 gallons inside a cabinet. What should we do with the rest of them?
Yeah, so what part of the OSHA regulations giving you the 60-gallon maximum? I mean, the limit, yeah.
It says, as I mentioned on the question, it says in the single storage area, but it was not clear for me. Single storage area, is it considered a control area, or one control area can have multiple rooms?
Yeah, so OSHA doesn't talk about control areas. So you could have, if you have a single storage area, 3 of them in one control area, and you don't exceed the 480, you've kept with the fire code. And if each storage area, each room is up less than 180 gallons, then you've complied with the OSHA regulations.
Okay, so we can have more than 3 basically flammable cabinets in one control area.
Yeah, sure, right, because a control area and a storage area are not the same definition.
Yeah, that was kind of confusing for me. Thank you for clarification.
Sure. Kevin, Angie, can you unmute Kevin?
Thanks, Russ. We came across a similar situation with a lab. It's in the design right now. I was at the impression if you had an NFPA 30 compliant liquid storage space, that would be considered different than a control area because it's not actually lab experiments and other research activity occurring. It's basically a storage use for flammables only. It would meet sprinkler hydraulic calculations for NFPA 30, fire separation, exhaust, and also the electrical classifications and such.
So, yeah, I mean, you can have multiple different types of occupancies in a single control area. It reduces the total amount you can have because you can, there's different occupancies have different limits, and so you're reduced to the maximum one. But if you have a S occupancy in a storage area and a B occupancy you're using for an office, or a B occupancy you're using for a lab, they can be in the same control area. You'd be limited to the B occupancy limits because those are less than the storage occupancy limits. The occupancies give you more flexibility if you can have more of them. You can use different occupancies for different parts of the building and still have them in the same control area if you want to.
Any other questions? Anyone want to raise their hand or put it in the chat? Oh, here's one. I'll let you read it, Russ. It's easy.
Yes. Alternative ways to store flammable liquid solids with hand sanitizers. Oh man. So one of the people that advise us on the software development that's part of the UC Fire Marshal world at Berkeley ran across like thousands of gallons of hand sanitizers that they were putting into little containers and distributing to the homeless at UC Berkeley. And so it was a challenge. You had to come up with what's the hazard classification of 70% ethanol. That's what they were using. And how can we store these in a way and distribute them throughout the building or buildings so that we don't exceed the limit in any one control area. It was a challenge. So I would suggest you using a fire fratted container that is equipped up. Yeah, sure. You could use separate exterior storage, safety storage, I think is one of the companies that make these containers just intended for that purpose. So you can store a lot of stuff out there, and you could make that could be an H2, in which case you could store as much flammable liquid as you could in that building, that separate building, or that occupancy. I've met Tony, Kevin. I haven't had the pleasure of actually working with him yet. So Chris has got a question.
Yes, Russ, can you hear me?
Yes.
Yes, a question I had was, when I look at these things, they say about using a flammable cabinets present, and you can use it. But what percentage of the flammables in a lab? Because the thing about these labs is some are in storage, some are in use. Is there a certain percentage? Because this was always one that's always bedeviled me before dealing with different people. I always assumed it had to be over 51%, roughly. I figured over half had to be in storage. Is there a certain percentage of the flammables have to be in a flammable cabinet before it's considered flammable cabinet in use that gives you that extra like sprinkler that's in a flammable cabinet, the extra increase in the MAQ?
So again, different fire safety professionals have different opinions on this. The strictest interpretation I've heard is if one bottle of a flammable is outside the cabinet, then you don't get approval for doubling. You don't get this approved storage credit for storing it in the cabinet. That always seemed a little harsh to me. I think it's NFPA 30 that talks about you can't have more than 10 gallons of flammable liquid in a room outside of the cabinet. I think that's a good thing to try and aim for. If all of the flammable liquids that are not in use are in a flammable storage cabinet, most fire marshals will say that's properly stored, because in storage it's you get the doubling for that value. But if it's in use, then it falls in a different part of the MAQ requirements and the limits. And the limits are smaller, but you know, if I was, so when I was a organic chemist, you know, we would leave just 5-gallon cans of flammable liquids sitting out on the floor, and had no idea that, that I should have put them away. You know, so some of it's education, some of it is like, oh, you know, this is what's going to happen. The fire at Rains Hall in 2001 was a real eye opener for a lot of people that were working in research at the time, because the fire started in the fume hood. They got pulled out into the room, and there was like 5 or 6 5-gallon cans of flammable liquid right behind them on the floor, and that's what caused the big massive thing. So encouraging people to store materials in flammable storage cabinets is always a good idea. And there's some negotiation with the users about how do you make this happen? What's the reason? Why do you have that in the first place? Kevin's got his hand up.
Hey, Russ, the question we come across on occasion is closed systems versus open systems. Is there a true definition anywhere that would describe what would be considered closed system? For instance, if you have a gas cabinet that's piped into a fume hood process, would that be considered a closed system?
Again, it depends on who your AHJ is, whether they'll approve it or not. I totally agree with you. I think open means that it's open to the common atmosphere where people are working in the laboratory. If it's in a fume hood, in all my experience, and the fume hood's working, that would be a closed system. So closed and open, there are definitions, but there's enough fuzziness in there that you really need to talk to the AHJ authority having jurisdiction to know what their interpretation is. But I totally agree with you, Kevin. If it's not in the same airspace as the people that are working in the room, like a glove box is a closed system unless you open the valve and, you know, it's exhausted into the room. And so there are some nuances, but I totally agree that that should be a closed system.
All right. Oh, one more, Christopher.
Yes, Russ, Chris Motter again here. Another question, because I've done a lot of these flammable assessments.
Sure. Yeah.
I'm just kind of curious, because when you say inventory, I'm not going to kid you. Looking on paper, I've never trusted any paper inventory ever in my life. First of all, the one weakness of all inventories on paper is you're relying on the end user actually obeying it, and most of the time they don't. But one of the things I did, and this is what I did when I was in industry, when I was in academia, I've actually got my hands and knees crawled around every single flammable cabinet, counting by liter each M-butyllithium, or I mean, I should say methyl-butyl ether, okay, hexanes, ethyl acetate, blah, 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 how many liters.
Sure.
To
Yeah.
get accurate. When you say accurate inventory, is that what you're referring to, is actually physically understanding what you're dealing with, or just going off of paper?
Yeah, no, so there's lots of challenges with an inventory, keeping it up to date, entering it in the first place. So if you can reconcile inventory, then I think that's accurate. We don't have anybody that I'm aware of using real time. I know where the bottle is that moves across the room, so I can tell you what it is. We have a system now that people can attach RFID tags to the containers. Then you can at least track the containers without having to actually touch every bottle. You know, an accurate inventory is a challenge. Part of the reason that the fire code interpretation in our world has been, we're going to count the size of the bottle, not the contents. So if the bottle's a gallon bottle, we're going to say that it's a gallon bottle until it doesn't exist anymore. And what that does is it allows a little access for, you know, the delay it takes for people to add new containers to the inventory, and it accounts a bit for the waste. You know, there's a recognition that there is some uncertainty in the work we do and the calculations we have, but complete accurate inventory, if you want to know the truth, then you have to know what it is you've got in the control area. What do you recommend to someone who is new to this? How can I get we're going to go to get more information on how to do the calculations. So the one table, I mean, the one table out of the fire code that describes, that gives you all the limits. Look at the footnotes, because the footnote, the devil's in the details. It'll say this is the number, and then it'll say you can increase by 100% if you've got a fully sprinklered system. And then you have to go somewhere else in the code to see what the definitions are, to see, what does it mean to be a flammable or flammable 1A, 1B, 1C. It is. We could develop a tutorial. We haven't yet. It would only be as good as whatever code year you're applying, because the 2001 code's different than the 2016 code, which is slightly different than the 2019 code, depending on what occupancy you're working on. So it's a challenge to keep up with. But I think Diana's trying to tell me to stop talking.
No, that's okay. You can finish that. I know people have to drop off other meetings, so I want to be respectful of everyone's time. I did drop in the chat. If you know how to use a reactions button and you want to give a little thumbs up and see if you learned anything or if this was helpful, you can do that for us now. If not, that's okay too. But okay, I see one clapping. All right, perfect. Please take a moment. We'll make the survey super short. We would just love to get your feedback. Also, other topic ideas. If you want to have a continuation, you can book time with us, even if you're not a client. We'll make Russ available, although it sounds like your authoritative fire authority is also a good resource. But thank you, everyone. We really appreciate your time and wish you almost happy weekend here.